The properties of joint distribution function here is for two random variables. Here we have considered joint distribution can be n random variables, but we have considered here for only two random variables, that is x and y. Okay, so the first property says that if x comma y of minus infinity comma minus infinity is equal to 0, if x comma y x comma minus infinity is equal to 0, if x comma y minus infinity y is equal to 0. This is our first property. The second property says that if x comma y of infinity comma infinity will be equal to 1. Students, you please note down this. Okay. The third property is that the joint distribution function will be having the minimum value 0 and maximum value 1. So it is 0 less than or equal to fxy of x comma y less than or equal to 1. Okay. The fourth property says that f x comma y of x comma y is monotonic non-decreasing function for both x and y. Okay. So it is non-decreasing function of both x and y. Okay. Now the probability of joint event x1 less than x less than or equal to x2 comma y1 less than y less than or equal to y2 is given by probability of x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is equal to what? fx of fxy of x2 comma y2 plus fxy of x1 comma y1 here minus fxy of x1 comma y2 minus fxy of x2 comma y1. Okay, so this is that. So if you want to find out the probability between x1 and x2, y1 and y2, it is nothing but what? The joint distribution function at x2 y2 plus joint distribution function at x1 y1 minus joint distribution function at x1 y2 minus joint distribution function at x2 y1. Okay, so the third property says that the marginal distribution functions are given by fx comma y of x comma infinity is equal to fx of x only, fx comma y infinity comma y is equal to fy of y. Okay, so these are the 6 properties of joint probability distribution function. Okay, now we'll see the proofs of this. The first proof is that, so here we have considered that only two random variables. Okay, what are the two random variables we have considered here? X and y. Okay, now the event A is defined such that A is equal to x less than or equal to x and B is equal to y less than or equal to y. Okay, then fx comma y of x comma y can be given as, what is the formula for fxy joint probability distribution function at xy is the probability of x less than or equal to x and y less than or equal to y. How do you write this? This can be written as probability of x less than or equal to x intersection y less than or equal to y. Okay, so now since what is that given? Capital X is equal to minus infinity. Okay, now we know that you don't have any event at x is equal to minus infinity. So what is the probability of x is equal to minus infinity will be 0. And similarly, we don't have any event y at x is equal to minus infinity, sorry, at y is equal to minus infinity. So the probability of y is equal to minus infinity will be 0. So at x is equal to minus infinity and y is equal to minus infinity, the joint distribution function can be written as what? It is probability of x less than or equal to minus infinity intersection y less than or equal to minus infinity. So you don't have any event at x less than or equal to minus infinity, no? Intersection, we don't have any event at y is equal to y less than or equal to minus infinity. Okay, so what is this intersection? This intersection will give us null set. So what is the probability of null set will be 0. Okay, similarly, if x is equal to minus infinity, okay, if x is equal to minus infinity, y will be same, y is same. So what is the probability of x less than or equal to minus infinity? is null set. What is x less than or equal to minus infinity is null set. Intersection y less than or equal to y. So you know that if any set intersection with the null set will give us what? Null set only. So what is the probability of null set will be? Probability of null set will be 0. Similarly, if you take y is equal to minus infinity, if you take y is equal to minus infinity, what happens? Y less than or equal to minus infinity will be, y less than or equal to minus infinity will be, what is that? It will be null set. So for x less than or equal to x less than or equal to x, intersection null set will be null set only. So probability of null set will be 0. Okay. So like that, this is our first property. What is first property? So fx of minus infinity will be equal to 0. Fx of minus infinity comma y is equal to 0. Fx of x comma minus infinity is also 0. Okay, so with this we have proved our first property. Okay, so fx of x comma minus infinity, fx of x comma minus infinity is equal to what? 0. Okay, so we have proved our first property. Now we'll see what is our second property. The second property says that fxy of infinity comma infinity. What is the definition, ma? Probability of x less than or equal to infinity. What is the variable you have here? Infinity, no? So same thing we have to consider here. Probability of x less than or equal to infinity, intersection y less than or equal to infinity. So if you take x less than or equal to infinity, what happens? It will consider all the elements in the sample space of random variable x. Now this will also consider all the elements in the sample space. Now what is that? First one will give us the sample space. The second one will also give us sample space. So probability of S intersection S, sample space intersection sample space will give us what? Sample space only. So the probability of sample space is equal to 1. Okay. So with this we have proved our second property. Okay. So from the first and second properties, we know that fx of minus infinity comma minus infinity. So what is that? Fx of minus infinity comma minus infinity is our first property, no? Fxy of minus infinity comma minus infinity is 0. Fxy of infinity comma infinity is 1. Okay. And we know that x value is varying from minus infinity to plus infinity. Y value is also varying from minus infinity to plus infinity. So the lowest value is minus infinity comma minus infinity, and whose joint probability distribution function will be 0. Okay. Similarly, highest value is what? Infinity, no? The highest value is infinity. Okay, so fxy of infinity comma infinity. So it is from the second property we know that the joint probability distribution function at infinity comma infinity is equal to 1. So from the first property and second property we can say that the joint distribution function will be varying from 0 to 1. Okay. And the fourth property. The fourth property says that if you take x1 comma x2 and y1 comma y2 be the two elements in the sample space such that x1 value will be less than x2, y1 value is less than or equal to y2. Now we have to show that the joint probability distribution function is monotonically increasing function of both x and y. Okay, it is increasing with both x and y. So now how do you write? You just observe this relation carefully, students. So here what is that we have taken? So we have taken a sample space. We have taken the element x1. Say for example it is starting from here. So x1 and x2. x1 value will be always less than or equal to x2. Okay. And what is y1 value? So here it is given y1 value will be always less than or equal to y2. We have taken like this. Okay. Now see here the first notation, x less than or equal to x1 and y less than or equal to y1. So what is that we have done? We have taken this part, x less than or equal to x1, y less than or equal to y1. Okay. Now, what is this part? x1 to x2. x1 to x2. x1 less than x less than or equal to x2. So x1 to x2 we have taken. Okay. Now y is less than or equal to y1 only. Y is less than or we are not taking the other part of y. Y we have taken only less than or equal to y1 only. Now what happens to x range? Can you tell me what is x range? Now since we have taken the two parts, x less than or equal to x1 and x1 less than or equal to x2, both we have taken. Y1 range we have taken the same thing. There is no change in the y1 range. So what is the total range for x now? The total range for x will be x less than or equal to x2, y is less than or equal to y1 only. Okay. Is it clear? Any doubts here? Now the probability, now we apply probability for this. Okay, so if you apply probability here, the probability of x less than or equal to x1, probability of x1 less than or equal to x less than or equal to x2, comma y less than or equal to y1, probability of x less than or equal to x2, y less than or equal to y1. Okay, now can you tell me what is this? This is nothing but the joint probability distribution function of x comma y at x1 and y1. So whereas this is the joint probability distribution function at x2 and x1. So it is at x2 and x1. Is it clear? So the first relation, what is the first relation? The first relation will give us joint probability distribution function at x1, y1, and the second this part, what is that we have on right side, that gives us what is that probability distribution function at x2 comma y1, because x range is what? x2, no? Y range is y1, so it is x2 comma y1. Okay, now from this relation, can you tell me what is probability of x1 less than x less than or equal to x2, y less than or equal to y1? So x1 less than or equal to x2, y less than or equal to y1 will be fx of x2 comma y1 minus fxy of x1 comma y1. So since x range is greater than here, the x range is x2, here x range is x1. So x2 is always greater than x1. So what is this value? This value is more compared to this. That is why, what is this here? The probability of x1 less than or equal to x2, see here mom, this notation. Probability of x1 less than x less than or equal to x2, y less than or equal to y1 value will be always greater than or equal to 0, because the joint distribution function at x1 y1 will be less than or equal to the joint distribution function at x2 and y1. Similarly, so here we have taken x range, we have increased x range, we have kept y range constant, no? We have changed, we did not change the y range. Now if you change y range, here x1 range we have kept, x range we have kept same, x range we have kept x1 only. What is y range here? It is y1, here it is y2. So since y2 is greater than y1, the joint probability distribution function at x1 y1 will be less than the joint probability distribution function at x1 y2. Okay, so from this we can say that the joint probability distribution function is monotonically non-decreasing function. It is increasing function. So okay, this is our fourth property. Okay, the fifth property says that since x1 is less than x2, y1 is less than or equal to y2, so x1 less than x less than or equal to x2, y1 less than y less than or equal to y2. Okay, so what is that given here? Say x range is given like this: 0, x1, x2. This is our x range. Okay, so the random variable x, and y range is given like this. It is 0, y1, y2. Okay, Now what is x1 less than or equal to x2 means x range we have taken in this direction, this part. Okay, this is our x range. And what is our y range? Y range is this part. Okay, so this can be written as, how do we write it as? So how do you get this relation? X less than or equal to x2 comma y1 less than or equal to y less than or equal to y2 minus x less than or equal to x1 y1 less than or equal to y less than or equal to y2. Fifth property is the joint probability of joint event x1 less than x less than or equal to x2, y1 less than y less than or equal to y2 is given as probability of x1 less than or equal to x less than or equal to x2, y1 less than y less than or equal to y2 can be written as the joint probability distribution function at x2 comma y2, joint probability distribution function at x1 comma y1 minus the joint probability distribution function at x1 comma y2 minus joint probability distribution function at x2 comma y1. Okay, now we'll see the proof of the fifth property. So just now we have discussed that. What is that? Here we are taking two events. Okay, so x range is 0. So here for example we have taken x1 like this and this is our x2. Okay, and similarly the y we have taken like this here and this is our 0, this is y1. So 0 I am taking that, we are starting from 0 like that. I have taken 0. X1 is the events at some location x1, x2 is the event at the location x2 like that. Okay, now here we have you see here, so what is given? X1 less than x less than or equal to x2. What is the range we are interested with? We are interested with x1 less than x less than or equal to x2. And what is the range of y? y1 less than y less than or equal to y2. This is the range of x1 and x2. How do you get this range here? So to get this range, what is x? We have taken as x is less than or equal to x2. X is less than or equal to x2 means what? Complete x range is, this is the duration 0 to x2 is x less than or equal to x2. There is no change in y duration, whatever is given in the left side, that is y1 less than y less than or equal to y2, the same thing we have taken, y1 less than or equal to y less than or equal to y2 minus, now what we have done, we are subtracting 0 x less than or equal to x1. If you subtract x less than or equal to x1 from x less than or equal to x2, what you get? So we will be getting this range. The range is x1 to x2. Yes or no? Now what is x range? X is less than or equal to x1. Y range is same thing. So finally if you subtract these two, what you get? We get x range as x1 less than or equal to x less than or equal to x2, y1 less than y less than or equal to y2. Okay, now what we do here, we so if you are, what is that we are doing here? See here, so to write here x1 to x2, see here to write the x range as x1 less than or equal to x2, how you have written? You have written x we have written as x1 less than or equal to x2 minus, see here, x less than or equal to x1. Okay, to get this range x1 less than x less than or equal to x2, what you have written? X less than or equal to x2 minus x less than or equal to x1. Okay, similarly to get y less than or equal to y less than or equal to y2, y1 less than or equal to y less than or equal to y2, how do you write it? We write it as y less than or equal to y2, y less than or equal to y2 minus y less than or equal to y1. So minus y less than or equal to y1. So similarly, the y range here can be obtained as y less than or equal to y2 minus y less than or equal to y1. Okay, now we separate this. We take x less than or equal to x2, y less than or equal to y2 minus x less than or equal to x2, y less than or equal to y1. Okay, this we are dividing into two parts, the x range and first y range. X range and second Y range. Since you have minus here, here we will be getting minus. Okay. Similarly, minus X less than or equal to X1, Y less than or equal to Y2. Minus and minus, minus and minus, it becomes plus. X less than or equal to X1, Y less than or equal to Y1. Okay. So now just now we have discussed that. What is this? The first relation. The first relation is nothing but the joint probability distribution function at x2, y2. The second relation is what? The joint probability distribution function at x2 and y1. And third relation is the joint probability distribution function at x1 and y2. And similarly, the fourth one is the joint probability distribution function at x1 and y1. Okay. So from this, what we get? We will be getting this as, see here, we'll be getting it as, so probability of x less than or equal to x2, probability of y less than or equal to y2. Now we apply probability on both sides. Okay. So if you apply probability on both sides, now the first equation, what is the first equation? Is nothing but the joint probability distribution function at x2 and y2. The second one is what? Probability distribution function at x2 and y1. The third one is joint probability distribution function at x1 and y2. And the fourth one is joint probability distribution function at x1 and y1. Okay. So that is our fifth property. And what is sixth property says? The marginal distribution function. So it is fxy of x comma y is equal to probability of x less than or equal to x, y less than or equal to y. This is the joint probability distribution function formula. Yes or no? From this, how do we write this as? It is probability of x less than or equal to x intersection, joint means what? Intersection. Intersection y less than or equal to y. Okay. Now, for example, if x is equal to infinity, if x is equal to infinity, what is that indicates? It is the sample space. Okay. So if x is equal to infinity, then how do you write it as? Probability of x less than or equal to infinity intersection y less than or equal to y. So the sample space intersection y less than or equal to y is what? It is probability of y less than or equal to y only. So if x is equal to infinity, the joint probability distribution function will be equal to what? This is the probability cumulative distribution function at y. Okay. So the joint probability distribution function will become cumulative distribution function if x is equal to infinity. Okay. Similarly, if y is equal to infinity. So if y is equal to infinity, then what happens? Y less than or equal to infinity is what? Y less than or equal to infinity will be the sample space. Okay. Now for x less than or equal to x intersection sample space will give us what? The x less than or equal to x only. So you know that any event intersection with the sample space will give us same event. So what is that? It gives us fx of x. Okay. So from this, what we can know? We know that the joint probability distribution function will be equal to what? Cumulative distribution function if y is equal to infinity. Okay. So that is fxy of x comma infinity will be equal to what? Fx of x. Okay. The marginal distribution functions of joint distribution are equal to individual probability distribution function. So if x is equal to infinity or y is equal to infinity, then what is that called? The marginal distribution function. If x is equal to infinity or y is equal to infinity, then it is called marginal distribution functions of joint distribution function is equal to what? It is the individual probability distribution functions. Okay. So that is fx of fx comma y comma x comma infinity will be equal to fx of x. Okay. Similarly, fxy of infinity comma y will be equal to what? Fy of y. Okay. So the marginal distribution functions are equal to what? Individual probability distribution functions. So with this, we have completed the proofs of the properties.